Kind of sums it all up. The only thing I disagree with this a little bit is I wanted more than 6 inches. Let's go with 8 or 10. Okay, well, this is not working that well. Let me try. There is something that's seizing this up. It just. Oh, okay. So maybe this is working. Okay, all right. So. Whoops, no, disappeared. Okay, so Gary Larson may have been a little bit off when he's going back to caveman time in terms of thinking about how important soils were. And I disagree with this a little bit. I'm gonna get rid of the chemists and the dirt and put soil scientists and soil there, because dirt's what you get under your fingernails. Soil's that really valuable stuff out in the environment. But he really wasn't that far off, because if you go back, we have a lot of information about soils, from even the Greeks, the ancient Greeks. And in China, over 2,000 years ago, they were mapping soils, and they were using these soil maps to figure out how much tax you would pay if you were a landowner. So if you had a more valuable soil, you paid more taxes. And so they obviously could recognize some of these properties and features of soil that would give better crops, better production. So let's talk about some of these characteristics of soil. So here we're going to go into a few bits of terminology and a little bit of detail. And I'm going to start with some of these physical properties that are particularly useful and important. Aggregation is one of them. And what I'm talking about is the fact that particles will clump together in soils. So, for example, right here, we have small crumb particles that are clumped together. These would be blocky aggregates. Here we have some columnar or prisms, so they're taller and narrower. And then we have platy structures that we get in soils, usually inherited from a parent material. Why do we care about aggregates? Well, we get bigger pore spaces between our aggregates. So that means we can have water and air move rapidly. Whereas inside the aggregates, that water is going to be retained a lot longer. And so it's going to be a lot more accessible to roots over a much longer time. So definitely aggregation's an important property. And infiltration rate. We want to get water into our soils. Have aggregates, you get bigger pores, it's a lot easier to get your water into your soil a bit quicker. This also, of course, is a factor in terms of erosion. That aggregation is going to help keep your soil stable and keep it where you want it and not heading off down the hill. Another one, really important property is soil texture. Now we're talking sand, silt, and clay. So if you take a thickness of a dime, that's about 1 millimeter, 2 thicknesses, 2 millimeters. We're talking everything that's less than 2 millimeters. So sand's everything you can see visually, from 2 millimeters down to those tiniest little particles that you're starting to have a hard time seeing. Clay is kind of at the opposite end. It's so tiny, you need a big microscope to figure out, individual clay parts. You cannot see them at all. Your hands can feel them though. If you have a moist soil and you start molding your soil with your hands will say, oh yeah, it's got clay in there. Silt is right in between. You might feel a little bit of grit from silt, from the bigger silt sized particles, and you might get right into that clay zone of feeling that moldability, but it's right in the middle there. So we have these 3 categories, and what they're put together is in a textural triangle. So what we're looking at right here is going from 0 to 100 in terms of our amount of clay that we have in the soil. Here from 0 to 100 in terms of the amount of silt, and then here from 0 to 100 in terms of the percent sand. And the triangle is then broken into different portions that are given a name. So What soil type do you think you want for texture?
Loam.
Of course, loam, yes.
It's green.
Yeah, there you go, that's right, it's colored green. But yes, loam is a great soil texture. You're talking about something that's about 20% clay, 40% silt, and 40% sand. Has a lot of those good properties, enough that you have some good physical structure, as well as some chemical properties that we're interested in. You're way up here in the clay box, that's not the ideal soil. Way over here in the sandbox, it's not so great either, but a little bit more workable than with the clay. And then silt again, not ideal. But anywhere near this clay box, around in this area, is gonna give you a good soil to work with. Okay, another thing is, particularly around here and around the Puget Sound, Mason County, we don't have just sand, silt, and clay. We can often get much bigger rocks and gravel. And yes, definitely a lot of that. But this will modify your texture. So you might see a soil name for a texture that would be like a gravelly, sandy loam. So still, okay, just know that those rocks and gravels aren't such a useful portion of your soil, but we've got to live with it. Okay. One of the other reasons that texture is a good thing to know about is that if you have big changes in texture, and remember your soil is changing with depth, if it changes with texture, that can really influence your water movement in your soil. So if you've got a coarse texture up here and then a finer texture down here, water will move rapidly through that, but it's going to kind of stop and slow down and pull up where you got that clay underneath it. So that's one other reason we care about texture. Okay, another one you may come across is bulk density. And this is just talking about if you go out there and take a core of soil or a cube of soil and you dry it out and you weigh it, it's the mass of soil per volume of soil. And we're talking a typical range here, somewhere around 1 gram. Think of it as like a nice dense fruit cake. You know, that's kind of in the range you want to have. You don't want a soil that's going to be so dense and hard for roots to penetrate that it's not going to be very useful. And you also don't want a soil that's going to be too fluffy, because if you have a really lightweight soil, you're not going to have good anchorage. You want your soil to, remember, to hold those plants up and keep them well anchored in the ground. Okay, moisture and temperature regime. Again, I put these up here because, yeah, we have kind of a uniform climate around here, but you can change moisture and temperature in your soils with some of the things that you do. So for example, if you drain the soil, then your soil is going to warm up faster. So you might increase, you know, the time when you start germination in your soil just by getting some of that water out, because water takes more energy to heat than a dry soil does. Okay, color. Very simple but useful property. If you're looking for dark brown, that's telling you got more organic matter in your soil. That's good. And by the way, excuse me, but I'm going to abbreviate organic matter throughout this with OM. Okay, iron. Think of that rusty color that you get from iron. That's going to tell you again, you have a reddish or yellowish or orangish color soil. You're looking at some iron oxide, some rust in your soil. And wetness, well, that's usually when we're talking about a very gray soil, if it's waterlogged all the time, or if you have splotches of orange and gray color, that can indicate that part of the year your soil is wet and part of it is dry. Remember, those roots want oxygen, so that could be an issue. And again, color is a simple thing that can help you figure out whether you have an issue with that. Lastly, again, very simple, just soil depth. More depth, more opportunities for roots to take advantage of more volume of soil. So again, a good thing to know about. Okay, well, let's look at a few chemical properties. And of course, I'm going to put pH up there right at the top. We're talking pH of 7 is going to be neutral, 1 to 6 acidic, 8 to 14 basic. Mostly, like a lot of crop plants, we want a pH between about 6 and 7, somewhere around that range. Though some plants like it a bit more acidic than that, others like a bit more basic. But in general, it's a really simple property, again, that you can check. And you can do even a piece of, with a moist soil and some litmus paper, you can simply figure out what your pH is. So right away, those are 3 really simple, easy to detect properties of your soil: pH, color, and texture, that I think are really useful to know. Okay, and I've mentioned here that all these soils around Mason County, they form under forests, and those forests were naturally acidifying the soil. So that's something that we always have to keep in mind too. Okay, organic matter content. How much and what type of organic matter have you got in your soil? You got a bunch of litter just sitting there on the top. Well, that may be very useful in the future, but it's not necessarily useful right now. What you're looking for is that, humified organic matter in your mineral soil, giving you that brown color. Okay. Nutrients. This is a little mnemonic that I always gave my students to help them remember all the nutrients. So you ready for this? Okay. C. Hawkins Cafe, managed by my cousin Clyde Moconi. There you go, you got them all. All right, so we don't have to worry particularly about carbon, hydrogen, oxygen. When the plants all got that covered. And you come over here and you've got iron and boron, manganese, copper, fluorine, molybdenum, cobalt, and nickel. Believe it or not, they've added nickel about 10 or 15 years ago. Those are all micronutrients, very, very tiny amounts that are needed by plants. And normally they're all okay. We don't have to worry about those either. Now, sulfur, calcium, magnesium, on occasion, we might have to think about those. In some rare cases, I would say, rare cases, particularly calcium, we might need to have additions of calcium to our soil, which you can easily do with carbonates. Mostly, what we're usually thinking about is NPK. And phosphorus and potassium, probably okay. Our big one that we have to worry about here is nitrogen. We have young soils, and that nitrogen is not necessarily abundant in our soils. So that's one where we might need to think about dealing with that. Okay, also the fact that you have a total amount of nutrients in the soil. If you were to break it down with acid and look at the whole thing, that would not tell you what's available to your plants. Something that's inside a rock or in a big piece of organic matter, plant roots aren't necessarily going to be able to take that up. What you want to know is more like what's available. So this is a term, cation exchange capacity, that's used to kind of identify what is actually able to be available to those roots to be taken up. And this is just a little example that we have here. So I've got a little clay molecule that I put right here. Got some ions attached to its surface. It's surrounded by soil water all around it. And in the water, you might have some ions, like this would be an example of aluminum ion. This is just one example. Well, that aluminum ion can actually bump off these, take its place, and put the calcium and potassium into solution, into that water that's out there, which, guess what? That water's right adjacent to the roots, and the roots are gonna go take it right up. So this is one way we can get nutrients to the roots. And in fact, plant roots are really adapted to this whole situation, because they will put out hydrogen ions. And the hydrogen ions do exactly the same thing as this aluminum I brought here. They pump out hydrogen, they go onto the clay surface, and they knock the nutrients up, take the nutrients up. So I said you didn't want too much clay in your soil, but you do want to have some. And this is one of the reasons you want some clay in your soil. Okay, not just clay will do this. Organic matter, well-humified organic matter will do exactly the same thing. Have these exchange sites where they can hold nutrients, but in an available form. And oxides, like, iron oxide, for example, will do the same thing. And I mentioned those oxides because we have volcanoes around here. We have volcanic ash that comes down and a bunch of oxides will form from that volcanic ash. Okay, one last one I'll put up here, waterlogging, oxidizing, reducing conditions. You know, like I said, those roots need oxygen. So we don't want to have so much water in our soil that our soil runs out of oxygen for the roots. And that's where, again, color can really help you figure out if you have an issue with waterlogging. Okay. Soil ecology, very big can of worms, bad pun there, but, now we're talking about a lot of the critters that are out there helping facilitate our nutrient cycling. We've got decomposers out there that are breaking down organic matter. They're physically shredding it, breaking it down, and they're chemically helping break it down and releasing the nutrients that were tied up in it. And we've got a lot of other friends out there in the soil that are helping, like this here are some nodules of nitrogen fixers on a small alder seedling. And those are, of course, helping get nitrogen into our soil. Remember, nitrogen is coming from the atmosphere, getting into the soil where then the roots can take it up. But all these different organisms are helping with this whole process of nutrient cycling. Okay, so let's step back a little bit now. And instead of looking at all these individual properties, let's start looking at soil more as a whole. And what I put up here is a couple different soil profiles. One that's from a bit north of here, one from a bit south of here, just as some examples of looking at entire soil going down, or close to the entire soil. And you see I've got a few letter designations here. So like I said, we're looking at whole soil profiles right now. So let's step back for just a second and look at what these are called. You notice with these that we've got different layers, right? And those layers are called horizons. So starting up here at the top, we have what we call an O horizon, the organic layer. This is litter that's sitting up there on the top of a soil. Very common under a forest soil. You go out to an agricultural site, there may be no O horizon at all. But partially or not decomposed at all, organic matter sitting on the surface. Down below that, this is what everybody wants. It's called the topsoil. This is the A horizon. And this is where you've got a mineral soil, but you've still got a lot of organic matter mixed in with it. This is what everybody wants to garden in. Now down below that, E horizon, there's none of those around here. You have to go way up, high elevation, the Cascades, and you might find some E horizons. It's just a zone where things have been leached out. Water's moved it out. Down here at the very bottom, the C horizon is where not much development's taken place in the soil. You pull out a handful and you look at those particles there, and you're going to see bare grains of quartz or other minerals and rocks. They don't have much happening there. The soil has development, hasn't gone down that deeply. Then in between, we have a B horizon. The B horizon is where you're going to develop mostly around here, orangish, tannish, reddish colors. And this is where you've got clays forming or accumulating. You've got oxides forming. You've got rocks being weathered and broken down. And so a lot of things are happening in that part of your horizon. So definitely a lot more formation right here. And so if we go back and look at these pictures for just a second, you can see this litter on the surface up here, that would be the O horizon. You can see a darker A horizon, not a very deep one. Some B horizons, and then the color's a bit off here, but that is a C horizon down below. This one here again, got the O horizon on top, a deeper A horizon here, kind of partially following an old root channel, and then a couple of B horizons right there. So now looking at this whole profile. Okay, so we go across the whole country There's thousands and thousands of different types of soils that have been mapped out there. Well, why do we get so many different types of soils? Well, because of these different factors here. You change climate, you go from a place that's really wet, like the Pacific Northwest, out to the east side of the mountains, total different climatic regimes, you're gonna get totally different soils. Organisms, so forest versus prairie, again, very different soil. Topography, if you're up on a hilltop versus valley bottom, again, that's gonna change your soil. Parent materials, I mean by parent materials is the rocks, that mineral part. If that changes, again, that's gonna change the type of soil that you have. And then lastly, how old, how long has the soil had to form? You may not even get a beat horizon until you've got a fair degree of development in the soil. Well, here in Mason County, mostly climate's the same, organisms are pretty much the same. Remember, everything was started forming under forest to begin with. So we've changed some of that today. Topography can give you some variation in it. Everything's actually pretty much the same age. So really, it comes down to the fact that our parent materials change. And that gives us a lot of the differences in the different type of soils that we have here. So, but to really understand this, we need to go back to the beginning, which means we need to go back to when the glaciers were here and leaving this area. So, for starters, we all know we had last ice age, big ice sheet came down from Canada, big lobe of ice covered all of Puget Sound, and changed everything. It pretty much erased any soils that were here before. Now, once that ice age starts to end, things can change. But while the ice was here, it was thousands of feet deep. Now that's a lot of weight pushing down. So we've got the ice grinding things along, carrying it, moving it, breaking it up, but it's also all that weight's compacting it too. So that has a big impact on what we see today. Okay, but then eventually ice age ends, 10,000 or so-ish years ago, ice is all melting off. We get Puget Sound being exposed because the Strait of Juan de Fuca is now open, things drain out, and we can start to form soils, again, new soils now. So everything's pretty much that same age. Ideally, we'd go back in time and look right down there below those glaciers and see what we have down there, but we can't quite do that. So we're going to take a little mini side trip here, and I'm going to show you some active glacial deposits from the Southern Alps in New Zealand. So right now we're looking at Mount Cook, and we're going to start zooming in on some of the glaciers all around Mount Cook. And this is one example of a glacier right here. You can see this thing is carving down this hillside, grinding out the rocks, moving it downhill. Things are compressed underneath, things are being, all new material being exposed. Another thing to notice is how dirty this ice is. There's not just rocks being moved underneath, but there's a lot of material that's fallen on top of the glacier, that's carried within the glacier, and it's all moving along too. So we got this loose stuff moving along with what we have underneath. Okay, now let's look at this glacier right here. And this glacier is retreating. So we have, you can see where the glacier used to go, and not too distant past, by this round here of moraines that were left. Loose material that was just shoved out of the way by the glacier. And it's just all mixed up material deposited there. But underneath this glacier, we're going to have that compacted material. And it's called either basal or lodgement till, but it's compacted. It can be dense. It can be almost like concrete in places. All this stuff, though, sitting on top of it, it's going to go down on top of that too. So you're going to wind up with loose material as well. And sometimes you'll see that referred to as ablation till. Yeah. Loose material deposited on top. And of course, then we have our moraines all around here, the terminal and lateral moraines here. a lake right here at the front of the glacier. Well, look at the color of that water. That water's carrying a lot of silt and a lot of clay particles in it. And it may be suspended in there right now, but eventually it's gonna fall out and it's gonna create another type of deposit that we can have from these glaciers. Okay. Coming off of this, we have a stream, and actually there was another big river going across the stream as well here too. This is called outwash material. You've got big flood events putting down big particles, summer light rainfall events putting down very fine materials. You're going to get materials that are very stratified now in terms of being outwashed upon. But eventually you can get a big whole floodplain of deposits that will be considered glacial outwash. The key thing here is that you can see, like in this example right here, they're stratified. They'll be coarse, fine, from all these different types of events in different years. Okay, so now we got a bunch of different parent materials to work with. We know that we're going to focus on a lot of that. We're going to start looking at some soils. And well, it's actually not a bad day outside, and even though Lucy doesn't particularly want to go out, Linus might like to go out and look at the field. We're going to go out and do a kind of a virtual field trip here and take a look at some of our soil around Mason County. And maybe you'll get into it like some of these students, because yes, some students really do get into it, believe it or not. Okay, so Mason County soils. Let's look at a few different examples here. And I'm going to start with the alder one because it's a very widespread soil, very common, not just in Mason County, but all around the Puget Sound area. This is one that forms on till, but it doesn't have just the compacted till at depth, though it certainly has that. It has a lot of loose material above that as well too. Texture, gravelly sandy loam, forms under forest soil. Now, is this an ideal soil? For a forest soil, it's not bad. Is it what you want to do your garden in? Maybe not particularly, but is it a soil that you could improve and work with? Absolutely. What would be the key thing that you want to add to this? Any type of organic matter, especially well-humified organic matter. Absolutely. And in fact, this here is an example of our natural alderwood soil right over here versus one that was from a nearby a developed area, where obviously this soil has been disturbed and worked, and clearly a lot of organic matter has been incorporated into this. And notice we got grasses on this one now too. Obviously, this has made a big improvement to that soil, at least in terms of the garden. Forests actually like the alderwood soil. It's not bad for forest soil. Okay, how about another one? One around here is the Shelton. Very similar. And by the way, in case you hadn't guessed, all these soils get their names from where they were first described. But the Shelton is pretty widespread in Mason County, though not necessarily around all Puget Sound. And we've certainly got glacial till down here. And you can see some of that till at depth down here. Gravelly sandy loam again too. Pretty good soil. You know, if you have enough depth, if your compacted till is down deep, especially for forest soil. Again, the same pretty much issues as you would have with an alderwood soil. Probably mostly you're going to want to add organic matter to the soil to help improve it. And what's another benefit to add to the alderwood and the Shelton, that organic matter? Well, that's again coming back to that nitrogen. So this is from a little greenhouse study where that little cedar over here had everything it could possibly want, all the nutrients it loved. Lush, nice, dark green foliage versus this one, which didn't get all the nitrogen it wanted by far. Didn't grow so well. It's a very pale yellowish color. It's called chlorata. And definitely a sign of, and a feature of having a plant that's not getting enough nitrogen. So Well, adding a lot of organic matter can help with this need for nitrogen that we have in our soil. Okay, another one here, Hartstein. This is kind of limited in area, but it is kind of an interesting soil, so I figured I'd include it. Again, we have glacial till at depth, but in this case, it's not quite as cemented as like we've seen with the last couple ones that we were looking at. Gravelly sandy loam also. This one was a little bit surprising to me, this particular area, because see how it looks pretty gray down here? What's that telling you? Not maybe enough oxygen, a little bit too much water. Well, it's kind of surprising to me because it's supposed to be kind of weakly cemented. You think water could go, but I think in this case, it was a topographic effect that we just didn't get enough drainage in this particular spot where we're looking at this soil. But again, you've got some A horizon up here. It's actually not too bad. It still probably could be useful to have more organic matter in it as well too. So overall, not too bad a soil. Okay, now for something completely different. The Sinclair. And this one is kind of scattered around in Mason County. Now we're talking about glacial till at depth, but you've got lake sediments on top. And remember, those lake sediments are going to be high in silts and clays. Usually you compaction around 2 feet. In this particular case right here, excuse me, I've got a little pin marking where you see you're at the top of the compaction. And above that, I don't know if you can see some patterns of layering right there. Again, now that's the lake sediments above that. And it kind of gets a little bit mixed up here to where roots have changed things a bit. So we're talking maybe a loam, but more commonly a silt loam to a clay loam in this upper part of your soil over your compacted till. Now, you've got some issues with this particular soil. You've got a very shallow soil. This is really something roots can't penetrate at all. So they're staying in this upper part of the soil. The soil texture is pretty fine. And another thing that's a common feature that you see with this soil are these little, they call them shots. They're dark, blackish nodules. They're actually from iron precipitating out. And that happens when you're having waterlogged conditions or oxidized conditions and reduced conditions where you don't have enough water. You don't have enough oxygen and you do have oxygen. So changing throughout the year, you can form these little shots. Again, another feature to tell you about possible problems with oxygen. So anyways, definitely issues with this soil. Just adding organic matter to this one probably isn't going to make it well enough to really be a good soil. In this case here, you might want to think about maybe adding some sand to the upper part, getting some drainage in as well too. And one of the things that can happen with this soil is because it's very shallow. Remember that last slide, I found that till it only like 18 inches down. You see these tree roots here. They're not going down. They're going sideways because they can't go down into that till. So that means you can get a lot of wind throw with this when you have bigger trees because the anchorage isn't great with this soil. Just not enough depth to your soil with that. So in terms of shallower crops, maybe you can work with it okay. And certainly trees are going to grow on it anyways. They're just not going to have as good an anchorage as you would like them to have. Okay, another one, Indianola. This is a really, really sandy soil. It's from outwash. Remember those rivers of water coming off the glaciers. It's another one that's really common around all Puget Sound, loamy sand, and it's pretty much sand all the way down through it. Some A horizon up here, and a lot of B. Eventually you do get to a C horizon. Very, pretty good soil actually for forest, except your water is going to be going through this a lot. So in this case here, you do want to try and hang on to water in your soil because you've already got a lot of oxygen. You want to add more nutrients. So again, adding organic matter is a good way to do this. I feel like I'm setting the next speaker up for the compost lecture. Okay, Everett. And I think there's another soil that's almost identical to Everett, very common around here called the Grove. They're basically the same, except for a slight difference in color. This is another one that's formed from glacial outwash. And this one here is from a road cut. I just put it up here so you would be able to get a bigger sense of these depositions from winter, fast, heavy moving water, heavy rock being deposited to in like the summer, and there's fine being put down. So a lot of stratified material here. Gravelly sandy loam to gravelly loamy sand, and this is really mostly what the soil is likely to see. So talking tan, yellow, tannish, orangish soil, thin A horizons, really not a particularly fertile soil, not a soil with a lot of water. You're more likely to see salal growing on this soil than you would be likely to see sword ferns growing on this soil. What are you gonna do with this one? And again, and organic matter is a good fix for it. You certainly don't want to drain it any more than it already drains itself. Because now in this case, we don't have any till at depth to kind of perch that water. Okay, one last one, the Kitsap soil. This is glacial lake sediments, and these sediments indeed vary in depth, but you know, easily be 6 to 8 feet deep with these sediments. And what you're looking at here, this profile here along the beach, is here's where the Kitsap is over a lot of these other glacial sediments. Both till and outwash kind of mixed down here. So now we're talking silty clay loam to silt loams that we have here. And I just got a little close up of how this clay looks in here. So not the ideal soil to work with, but this is what I get to work with. This is my soil. And I've still got my vegetable garden that I get out there on this. So what did I do with this soil? Number one, I added organic matter to it. Just adding organic matter wasn't going to quite cut it. I put in a bunch of sand as well. Raised the pH a little bit. And I wanted to think about drainage as well too, because this is soil that, you know, it gets really muddy in the winter. Not something you want to be driving on because again, bad physical properties. But what I did was I also mounded it. So I have beds that are about 8 inches high that are just mounded with my better soil, still have my clay soil underneath. So that's helping keep the water in there. But I do have drainage in the part where I'm putting my squashes and my corn. My corn can still go down into that silty clay loam, but it's got a lot of good stuff to work with above that. But the silty clay loam can still help anchor it. So again, there's different ways you can try to help fix some of the soil that you might have on your particular property. So how are you going to figure out what you've got for your soil? Well, I'm going to put this up here because the Natural Resource Conservation Service is the one that does the mapping with soils. And it used to be the Soil Conservation Service, but now the Natural Resource Conservation Service. You can go to their website and you can try and figure out exactly what your area is mapped as. And so here would be a little more detailed map like you might find in Mason County for your soils. I'm going to tell you right now, this is not a user-friendly program. And yes, feel free to try it and maybe you'll disagree with me. I personally say, what were you thinking? But anyway, however, I have an alternate for you. If you have an Android phone, I do not know if this works with iPhone, but if you have an Android phone, there's a little app called Soil Web. It's easy enough to download, and all you have to do is have your location turned on, and it will tell you what soil you're standing on right there. So at least that would tell you a particular point in there. So you might want to try that and see if you can do it. And then, okay, and then lastly, I'll just put this map up right here for maybe you can start thinking about what type of soil that you have, where you're living at and where you're gardening. And this is one from the soil, the conservation district right around here. Okay, so thank you for your attention.
Are there any questions? I have a question, Darlene. If you're digging in soil like at the Catalyst Garden, we're not seeing worms, we're not seeing small invertebrates. What's going on with
What
that?
color
soil?
is it?
What's up?
What color is it? What pH is it? What texture is it?
Pretty dark and, I don't know what the pH is. Does anybody back here know the pH? For the Catalyst soil?
But we've added a lot of, it used to be, okay, the pH, we haven't done it in.
They lime it occasionally,
Occasionally,
every
okay.
maybe 5 years or so, it gets limed. And,
Okay, well, I can't tell you exactly without maybe looking at it a little bit more. But that said, we're in an urban environment now all the time. And I didn't really mention a lot of this, but there are things that can truly damage your soil. For example, a really common example around here is there used to be a big copper smelter, the Asarco smelter in Tacoma. That thing pumped out nasty metals, let's just say, for many, many years. So if you lived on the south end of Vashon Island, your soil has contaminated with a lot of trace elements, trace metals in particular, cadmium, copper, et cetera, so forth. We don't have to particularly worry about there because the prevailing winds took it the other way. Nevertheless, in certain other urban environments, and I don't know about this particular place, if you might find, from cars, from just a lot of types of different pollution, you can get certain types of organics that get into your soil that actually can become a problem to different organisms in the soil. I think that's probably more the exception though than the rule. My guess is it's more some other more basic property if you're not seeing a lot of critters in your soil. Have you looked at it with a hand lens and looked at, I think
no,
about
they
that.
do bring in soil and compost and manure and stuff like that and revitalize it every year or 2 years.
Huh, seems like that would certainly help.
Okay. Any other questions?
Okay,
Okay, thank you, Darlene. That was great. Oh, we actually have a couple Zoom questions.
okay.
Read them?
Yes, or I think actually just one, which was, is compact till, does that mean hard pan?
Okay, it can mean hard pan. Some people would just call it, refer to it as a hard pan. Because honestly, there are times when I have basically tried to get into the till and you can chip it with a pick. And it's that hard. It almost feels like concrete.
And
Okay.
then one more, you mentioned that different soil profiles favor the growth of certain plants. Is there a reference that shows what plants grown on a particular soil type in order to tell what kind of soil is underneath?
Well, don't we wish? No, the answer to that one, I'm afraid, is no. There is no key plant that will tell you. The only thing, like I mentioned, if I knew I was in an area where I was having like an Everett versus an Alderwood, I would look to see, because I would know that on that Everett, there's gonna be Salal. Whereas on the Alderwood, I'm gonna find sword ferns if I'm under a forest, for example. And that would actually help